Okay, guys, we start recording at the previous time. Sorry, I forget to start recording from the beginning. Thank you, Mohammed, for bringing this to my attention. At the beginning, we discussed last week the tuples and list question. Group 1 did a great presentation, and the students also interact with these and have some question and some clarification about this, but nothing new. Now we are talking about the midterm exam. Next week, there is no class, November 1st, because it's the reading week. The week after is November 8th, which is the midterm day. Today, we will cover week 6 and week 7, which is, it's not week exactly. It's, topic 6 and topic 7 in our course outlines. We will start with them shortly. But at the beginning, we are taking voting to have our midterm. We have two options, either 6 to 7 at the end of the class. And we'll talk about object-oriented at the beginning in week 8. It's object-oriented programming, the handout will be. Or we start with the midterm exam from 4 to 5, then 6 to 7:30 will take the week 8 slides. So the first voting will be 4 to 5. Are you okay, guys, to start 4 to 5, the exam?
Yes, Professor, I prefer to 45.
Any objection? If there is no objection, I would assume that everybody is agreed to have it 4 to 5. Okay, so our exam will go from 4 to 5. It would be like some true, false, multiple choices questions, and then short answers. In more questions, we'll talk about it at the end of the class. It's always, quiz 1 was simulating the midterm, but it's at larger size. For accommodation, it's considered the exam does not require more than 25 minutes to be answered. However, I'm giving you 60 minutes. So more than 100% of the required timing would be given to the student. So all students with accommodation that require extra, those who are requiring extra time to do their exam, it's already under consideration with this timing. Okay, guys. Please, I will send an announcement about the midterm, and I'm giving you almost 2 weeks. Every student should join 3:55 to the exam. Make sure your camera is working, because during the exam, I'll make 2 recordings that day. The first recording based on the university requirement for proctored assessment, that your camera should be working. So if you have an issue with your camera, please make sure that it's working before the exam. Last quiz, I gave some exceptions because the announcement was sent maybe late, but today I will send an announcement regarding the midterm exam that your camera should be on. Other thing, you should join to Zoom using your UWO email, not your personal email. 99% of you guys are doing this. What else? During the exam, nobody should be around you. I should see you that you just concentrate on your screen to answer your exam. Is that okay, guys? Clear? I'll send the exam instruction in the announcement. Just the only thing, your camera should be working. If you don't have like a laptop with camera or something, please arrange. You have 2 weeks to arrange for that session. It's 1 hour. Then I'll stop recording, end the class. Then at 6:05, we'll rejoin and start recording as a normal class with object-oriented programming chapter or topic, which will be called week 8. So I'll start now with week 6. And as I told you, any group has any question about the proposal, clarification, group 7 will be answered first. Then any other group, please wait, and I will be more than happy to answer your question. Okay, share screen. Yes, share. Are you seeing my screen, guys? Week 6?
Yes, Professor.
The full screen or the one with the black?
Yes.
The full screen. Okay.
Well, that's true.
Okay. So today we will talk about 2 topics at the beginning: recursion and dictionaries. What do we mean by recursion? What do we mean by dictionaries? And how we can implement those in Python. Last week, we talked about the tuples, immutable, lists are mutable, aliasing, cloning, mutability, side effects. Today, we'll talk about recursion, divide, decrease, and conquer, dictionaries, another immutable object type. We have the list, and today we will introduce the dictionaries, which are mutable. Recursion. What do we mean by recursion? Recursion is the process of repeating items in a self-similar way. For example, if I say ABC, the recursion will give me CBA, which is the other direction. The very last item would be the first, and the very first item would be the last, which means like you're changing direction. If you go from the sport complex at Western, then you will find at the left side the TEB. Then if you move further toward the roundabout of the university at the alumni hall, then you will find at your left the next building would be, what is it? SEB, Spencer Engineering Building. If I said to you, make a recursion, then you will go other way. Then you will find SEB at the first, then TEB, then the sport complex. Is that clear, guys? What is a recursion? In the language of algorithm, or computational algorithms, a way to design a solution to problems by divide and conquer or decrease and conquer. Reduce a problem to a simpler version of the same problem. So when I say recursive in a general language, the very first end would be the last, and the very last would be the first. But in a computer, I'll make the function call himself. Why we do that? We use a concept, we call it divide and conquer. When you divide the problem to smaller pieces, or decrease and conquer. Then you can simplify the problem and find the solution in a better way. If we talk semantically, a programming technique where function calls itself. This is a recursion. In the programming, goal is not to have infinite recursion. So I'll not let the function call himself forever. There is a stop condition. There is a stop condition. So must have one or more base cases that are easy to solve, must solve the same problem in some other input with the goal of simplifying the larging problem input. Why we use recursion? To solve the same problem in a way simplifying it than traditional way. How's that will be? Iterative algorithms so far. Looping construction, while and for loops lead to iterative algorithm. We are repeating iterative. Each iteration we will process certain line of codes. Can capture computation in a set of state variables that update on each iteration through the loop. So multiple iterative solution. Multiply A times B is equivalent to add A to itself B times. You remember when we were at early school classes, grade 2, 3, I don't know, based on your system, when you have been introduced to the multiplication. The first thing that the math teacher will teach us 5 times 2, that you are adding 5 to itself 2 times, then 5 plus 5 equal 10, or 5 times 2 equal 10. When I say 5 times 4, which means it's 5 plus 5 plus 5 plus 5. Do you remember this at early school grades? This is how we have been introduced to multiplication. Capture state by an iteration number I. Start at B, where I will become to I minus 1 and stop when 0. This is the recursion. So we start with the last state, then we move to the first state to stop the loop. That's why we call it recursion or self-calling iteration. A current value of a computation is a result. So a result will be equal result plus A. This is how we do the multiplication by recursive. How we do that? Again, when I say 5 times 4, then I'll make a loop for I equal 4 and step minus 1 every time. I equal 4, I equal 3, I equal 2, I equal 1, and stop when 0. So each time I equal I minus 1, then I will add to the result 5 plus 5 plus 5 plus 5, and I stop. This is how the recursion concept works. In our example here, def multiplication iteration A and B, you will send 5 times 6. Result at the beginning equals 0, while B greater than 0. This is how we start with it. Result equal A, result plus A, this is mean. B equal B minus 1. Then at the end, once the loop stop, return the result. So current value of computation are running some current value of iteration variable, this one. And here's the iteration. So we start from the very last item till we reach to 0. This is how we do it, iteration, but this is in a traditional way. This is in a traditional way. How we do it in a recursive function? Recursive step, think how to reduce a problem to a simpler, smaller version of same problem. So here, A times B, A plus A plus A plus A, B times. Here, how we do it? It's A plus A times B minus 1. This is the recursive reduction. So if I say 4 times 5, in this way, I'll make it, it's 4 plus 4 times 4 this time. Because B was 5, I take it 1 outside, then make it 4 times 4. In the second recursive, it will be 4 plus 4 plus 4 times 3, like this. So how I do it in the programming, def multiplication A and B, if A equal 1, return A, done. Else return A plus mult A with B minus 1 recursive step. Questions still here? Is that clear, guys? What do we mean by recursive? We are how we simplify it. We take the first item of the 4, then we do the multiplication with a recursive step, which is with n minus 1. And we call the same function, and we send to them the original, which is the 4 in our example, times 4. Then it will go. It will receive here 4 and 4. Does it equal 1? No. Else it is 4, and we have 4 from the beginning, which is 8 plus 4 times 3. Then 4 times 2. Then 4 times 1. Once we reach to 1, then they will return A, which is the multiplication result. Is that clear? So multiplication calling himself with the recursive step. And here is the base case. Clear? Here, with more complicated example, do you remember the factorial in mathematics? Anybody don't know what do we mean by factorial? Who can tell me what is the factorial of 3?
Six.
Simplify it to your colleagues. It is a 3 by 2 by 1. What do we mean by a factorial, which is the number, then explanation mark? That means in mathematics, the number n, I have it. If I say 5 factorial, then it is the result of 5 times 4 times 3 times 2 times 1. Which is in mathematics, whatever the number is, it is n times n minus 1 times n minus 2 times n minus 3 times till we reach to the number 1. So what is simpler, to calculate it manually or to have a function? If I ask you to do it using for loop, then I have to ask you to input the number first, then I can use that number to do the loop to calculate the factorial in traditional way. But why to do all of this? I'll do a recursive function. Whatever the number I enter, it will call itself till it reaches to 1. And I don't have to identify the number from the very beginning. So for what n do we know the factorial? If n equal 1, then return 1. This is what we know. How to reduce the problem? Rewrite it in terms of something simpler to reach base case. N equal n times n minus 1 factorial, right? In mathematics, this. N equal, if it's 3, so it is a 3 times 2 factorial. What is 2 factorial? It is 2 times 1 factorial. So n 1 factorial is the base case for us. So why to do it in a recursive step that every time return to me n times the factorial of the n minus 1 number. And in this way, we don't have to know how many times I have to do the for loops. Correct, guys? So I'm doing a loop without using a loop. This is the recursion. So what is the scope of recursive function? So if I have defining the factorial of n, if n equal 1, return 1, else return n factorial times factorial n minus 1, then print here fact 4, which means 4 times factorial 3. Then for the factorial 3, it will be 3 times factorial 2. Then in the 2, it will be 2 times factorial 1. And when we reach to factorial 1, we reach to the base case, which is 1. So it will be 4 times 3 times 2 times 1. And I don't use any for loop. I don't have to know the number 4 from the very beginning. Any number I can send, it will calculate the factorial without determining the number of loops that I require. So we have the global scope, which is the factorial sum code. The factorial scope call when n equal 4. Then it will call the factorial scope when n equal 3. Then when n equal 2. Then when n equal 1. Then we have the base case. Then we will return to calculate 2 times 1, which is 2. Then we'll here have the 3 times factorial 2, which is 2 here. Then we'll go to 4 times factorial 3, and so on. Is that clear? Clear, guys? Question still here. There is a question in the midterm about recursion. From time, this is a hint to all students. You should get, all the class should get full mark on this question. What do we observe from the recursion? And the next slide, we'll compare between recursion and iteration. We'll put 2 code of the same example, 1 by iteration and 1 by recursion, and we'll see what are the differences. So the sum observation, the first one, each recursive call to a function create its own scope environment. So at each call, we have its own scope and environment. Binding of variable in a scope are not changed by a recursive call. It will not change. The computer will memorize each scope values. Flow of control passes back to the previous scope. So we'll go forward, then the result will come from the very end till we reach to the very beginning. Okay, guys? So using the same variable name, but they are different objects in a separate scopes. And we talk about the scope not in last week, the week before. Go back to week 4, then you will find when we talk about the scope. So now we'll compare between iterations versus recursion. So in iteration, define factorial iter n. Production equal 1 for I in range 1 to n plus 1. Product times I, return prod, which is, but if you look here, factorial, if n equal 1, return 1, else call yourself. Simpler code, easier to read, easier to understand, rather than why we use n plus 1, why we use 1. Recursion may be simpler, more intuitive. Recursion may be efficient from programmer point of view. As a programmer, as a complexity, as not to determine the number of iterations from the beginning, but here I have to send it to the function. For then recursion may not be efficient from computer point of view because it will call a lot of function and it consume more memory, but it's more efficient. Clear, guys? What do we mean by inductive reasoning? Let's answer this question. How do we know that our recursive code will work? Multiple iteration terminates because B is initially positive and decrease by 1 each time around the loop. Thus must be eventually become less than 1. Called B equal 1 has no recursive call and stops. Mult call with B greater than 1 make a recursive call with a smaller version of B must be eventually reach a call with B equal 1. So as a kind of inductive proof or inductive reasoning, so the multi-iteration will be stopped when B is initially positive. But what if I ask for a negative number multiplication? Then I have to create another value of B less than 0. Then take another value with positive, then use that one for loop. But with multiplication, with multi, it would be a way easier with recursive. Mathematical induction. Do you know what do you mean by mathematical induction, guys? You should have it grade 8, grade 9, in some countries grade 7 in mathematics. To prove a statement index on integers is true for all values of n, prove it is true when n is the smallest value, for example, n equals 0 or n equal 1. Then prove that if it is true for an arbitrary value of n, one can show that it must be true for n plus 1. And this using the pigeonhole concept. Are you familiar with pigeonhole concept? Yes or no? Engineers?
No, Professor.
You never been introduced to pigeonhole concept in mathematics in high school or grade 8, grade 9? Let's take this example. And if you have any more clarification, we can talk about it, okay? Then we have to prove that 0 plus 1 plus 2 plus 3 plus whatever till n equal n times n plus 1 divided by 2. The pigeonhole concept, guys, you can Google it to understand it. The pigeonhole concept is saying that if I have an pigeon and flies and birds, and I have a house for them, then there should be a place to accommodate n+1 pigeons. This is a very known concept and in mathematics. So how we prove this one? By using mathematical induction. If n equals 0, then the left-hand side is 0 and the right-hand side is 0 times 1/2, which is 0, so true. Assume true for some k, then need to show that 0 plus 1 plus 2 till plus k plus 1 equal k plus 1 times k plus 2/2. So the left-hand side is k times k plus 1/2 plus k plus 1 by assumption that the property holds for a problem of size k. This becomes an algebra k plus 1 times k plus 2/2. Hence, exceptions holds for all n greater or equal to 0. So as I told you, the mathematical induction depend on pigeonhole. If I have a k cells for pigeon, that it can accommodate k plus 1 pigeons. So every time we have to add k plus 1 by assumption that can hold size of k. How we can connect this to code? Some logic should be applied. So mult a times b, if b equal 1, return a, else, which means if I said a times 1, then it is a. This is what do we mean by if b equal 1. Else, return a times mult a b minus 1. Base case can show that mult must return correct answer. For recursive case, we can assume that mult correctly returns an answer for a problem of size smaller than b. Then by the addition step, it must also return a correct answer for a problem of size b. Thus, by induction, code correctly return an answer. Don't worry, guys. As a programming, we should introduce the mathematical induction concept and the pigeonhole concept, but I'll not ask you to use or to prove using mathematical induction. Maybe in a quiz 2, we should have some example about this, and it would be more clear. For the midterm, I'll not ask you about this, because I know some students, they might don't have any previous knowledge about this, and it's not the time, or we don't have time before the midterm to explain this. But if you have any question, even during the reading week, just send me an email and we can arrange for a Zoom meeting and I can explain in more details. Towers of Hanoi. What is the story? We have 3 tall spikes, stack of 64 different size disks, start on a spike, need to move a spike to second spike, at which point universe end, can only move 1 disk at a time, and a larger disk can never cover up a small disk. So this is the Tower of Hanoi problem in programming. To continue, having seen a set of examples of different size stack, how would you write a program to print out the right set of moves? There is a condition at the beginning that what is the limit? No disk or larger disk could cover a smaller disk below it. So we need to do certain moves to satisfy these conditions. How we'll do it? We'll think recursively. Solve a smaller problem, solve a basic problem, then we will solve a smaller problem recursively. So, definition of print move. from 2, print move from string of R to string 2, definition the towers and from to spare. We should have a spare to take the moving to it. If n equal 1, print move from 2, else towers n minus 1 from spare 2. Then we'll call the function itself and send from to spare. Then in the next one we'll pay. So this is to do the move. Did you get the example, guys, or I have to clarify? So in any move, I'll move from tower to tower. I have 3 towers. The first tower we'll call it from, the second tower 2, the third tower is spare. So if I have a bigger disk and I need it to move it with, and below it there is a smaller disk, how I can do that? I have to take the bigger disk at the beginning from the tower from, put it in the spare, then move the smaller one to, then take it again, then to do the replacement and make it correct. And I will keep doing that till the whole thing and n become equal 1. Now, another example where recursion is very effective, or recursive function is very effective, when we use the Fibonacci sequence or Fibonacci number. So he modeled the following challenge. A new pair of rabbits, 1 female, 1 male, are put in a pen. Rabbits mate at age of 1 month. Rabbit have 1 month gestation period. Assume rabbits never die. That the female always produce 1 new pair, 1 male and 1 female every month from its 2nd month on. How many female rabbits are there at the end of 1 year? To understand the example, we have these 2 rabbits. They become big. They have 1 male and 1 female. And then the next month they are doing this. And it's continue till we have 1 year, all of those rabbits. So Fibonacci sequence, after 1 month, call it 0 minus 1 female. After 2nd month, still 1 female, now pregnant. After 3rd month, 2 female, 1 pregnant, 1 not. And then females and plus 1, females and minus 2. Every female alive at a month and minus 2 will produce 1 female in a month, and these can add those alive in a month and minus 1 to get the total alive in a month. So this is Fibonacci challenge. We know it in mathematics. Then the recursive case, female n equal females n minus 1 plus females n minus 2. How we do it? Do you know Fibonacci sequence? It's 1, 1, 2, then 3, then 5, like this. Do you know it in mathematics, guys?
Yes, we also did it in the assignment.
Yeah.
Yes, the one we did in the assignment. That's why I put it in the assignment, and here how we solve it recursively. So assume x an integer greater than 0, return Fibonacci of x. If x equals 0 or x equal 1, return 1. Else return Fibonacci of x minus 1 plus Fibonacci x minus 2. Then it will be called till we reach to 0 or 1. You see how much it's simple here with recursive? It's different than how you solve it in assignment 1. Right, guys?
Yes, it's simple.
Yeah. Recursion on non-numerics. Can we use recursion in non-numerics? How to check if a string characters is a plain drum? For example, read the same forward and backward. Abel was I saw Elba. Attributed to Napoleon. Are we not drawn onward? We few drawn onward the new era. Attributed to Anel Michels. So these two strings, if I read it from left to right or from right to left or left to right, it would be the same. So the first one is attributed to Napoleon, then the second one is attributed to Anne Michels. So how we can solve them recursively? Convert the string to just characters by stripping out punctuation and converting uppercase to lowercase. Then base case, a string of length 0 or 1 is a plain drum. Recursive case, if first character matches the last character, then is plain drum. If middle section is a plain drum. So we'll keep checking to see. With the example, A is a plain drum. Then we'll take them out. Then we'll check B, the third one, the fourth one, till we reach to the middle. How we'll do it programmably is a plain drum for us. If two characters, we change it to lowercase for C in S. If C in the alphabet, answer equal answer plus C, return answer. Def is plain drum. If len S less than equal, return true, else return S0 equal S minus 1, and is pal to the very end one, and return the function and the new characters. Is that clear, guys? This is how we do it recursively. So an example of divide and conquer algorithm: solve a hard problem by breaking it into a set of sub problems such that sub problems are easier to solve than original. So if I say factorial of 6, which is easier to solve, factorial of 6 or factorial of 5? Factorial of 5. Then when I divide factorial of 5 to 5 plus factorial of 4, then I make it simpler till I reach to factorial of 1. So we are changing it to sub easier problems. So we are solving hard problems by breaking them or breaking the problem or breaking it into a set of sub problems. That sub problem are easier to solve than the original. Solution of the sub problem can be combined to solve the original. This is what do mean by divide and conquer. Dictionaries. How to store student info. I ask you to make a program that stores student info and print them out. How we can store them? So far, can store using separate list for every info, like name Anna, then John, then Dennis, then Kathy, grades B, A plus A, and then the course numbers or whatever. A separate list for each item. Each list must have the same length. Info stored across list, same index. Each index refer to info for different person. So like name 0, grade 0, and course 0 are for the same person. Name 1, grade 1, course 1 as the index, it's giving the same person who's John. How to update, retrieve student info. Def get a grade student, name list, grade list, course list, I, name list dot index student, grade list lal I or course lal I, return course and the grade. This is very messy if we have a lot of different info to keep track of. Must maintain many lists and pass them as arguments. Must always we have the index using integers. Must remember to change multiple lists. So it's very complicated option to just use the lists or separate list for each thing. And if I have a lot of students, a lot of information, how I can retrieve them or remember them all. A better and cleaner way, then we will use a dictionary. Nice to index item of interest directly, not always integer. Nice to use one data structure, no separate list. So we can combine these lists in one, use the index that we want, and it's cleaner. Here, a list is index element, a dictionary key, custom index label, like student ID, then the dictionary, whatever the value and elements that we need to enter. A Python dictionary. Store pairs of data, the key and the value. How we define it? We say my dict equal empty dictionary. Grades, Anna, B, John, A plus, Dennis, A, Kathy, A. So here we combine them together in a dictionary. So once we use the colon, that means it's another item or another value of the dictionary. So similar to indexing into list, looks up the key, return the value associated with the key. If key isn't found, you will get an error. So if I'll ask for the grade of Anna, I write grades John, it will give me A plus. Grade Sylvia, Sylvan, it will give me error because we don't have Sylvan here. So it's easier than saying here, for names of 0, print grade of 0. With dictionary, it is simpler, cleaner. How we do it? We create it. We said grades, my dictionary, whatever I call it, then I can separate the values with the colon symbol. Dictionary lookup. Can we have a lookup for the dictionary? We'll see. Similar to indexing to list, lookup the key, returns the value associated with the key. If the key isn't found, get an error. I'm repeating this because it's very important, guys.
Professor,
Yes.
I don't need to use the print command here to print grades June.
No.
This
It will
will
give me immediately. That's why dictionary are good. We call it lookup using the key, which is the student name. We use the student name as a key. Okay. I don't have to use index 0, 1, 2, 3.
Okay, thank you.
How we add to dictionary? If we have grades Anna, John, Dennis, Kathy, the original one that we have, we need to add Sylvian. Then we said grades Sylvian equal A. Test if key in dictionary, we ask John in grades, it will return true. Daniel in grades, it will return false because we don't have Daniel. Delete entry, we said del in grades Anna, remove the student Anna grades and record. Add, test, and delete. We have 3 operations till the moment. Add, test, and delete. Grades Anna B, John A plus, Dennis, Katie. Get a tuple that act like a tuple of all keys. Grades dot keys it will return to you all student names, all keys that you use. Get an iterable that acts like a tuple of all values. Grade.values. It will give you all grades. But there is no guaranteed order, depend which memory location is used. Clear, guys? If you see, it doesn't give me the same order I enter them. Values, any type. Immutable and immutable. Could be anything you needed. It could be a list, the values. It could be a list or tuples, whatever. Can be duplicates. Dictionary variable can be list, even other dictionaries. You can make the value another dictionary. Keys must be unique. So if I have Anna, I cannot have another Anna because it's a key. Immutable. The type it's taking, integer, float, string, tuple, Boolean. But it couldn't be list. Actually need an object that is hashable, but think of as immutable as all immutable type are hashable. Careful with the float types as a key. Be careful on this. No order to keys or values. D41013, this is tuple 12. Const, which is a string, have this list. List versus dictionary. Order sequence of elements matches key to values. Here it's an ordered sequence of elements. Look up element by integer index. Look up one item by another item. Indices have an order. No order is guaranteed. Index is an integer. Key can be any immutable type. Okay. Example 3, functions to analyze song lyrics. Create a frequency dictionary mapping string to integer. Find word that occurs the most and how many times. Use a list in case there is more than one word. Return a tuple list integer for word list highest frequency. Find the words that occur at least X time. Let user choose at least X times, the value of X, how many times you want that word repeated. So allow as a parameter. Return a list of a tuple. Each tuple is the list and the number of repeating containing the list of words ordered by their frequency. Idea. From song dictionary, find most frequent word. Delete most common word. Repeat. It works because you are mutating the song dictionary. To create the dictionary, def lyrics to frequencies, lyrics, my dict empty at the beginning. For word in lyrics, if word is in my dictionary, then my dictionary for word +1, else my dictionary for word equal 1, return my dictionary. So can iterate over list, can iterate over keys in dictionary, update value associated with that key. Then using the dictionary, defining function, most common words frequencies, value frequencies dot value, best max value, words for k in frequencies. If frequencies of k equal best, then word dot append k, return word and best. Leveraging dictionary properties, def word often frequencies minimum times the result done false, while not done temp most common words frequencies. If temp of 1 greater than the minimum of time, then result dot append temp. For W and temp 0, diff frequencies W else done true, return result print words of L. I attach the code of all of those, then you can see the Python tutor and it can show you in the memory how it's working. Can dictionary make it easier to iterate? Fibonacci recursive code that we talk about. Fib n, if n equal 1, then return 1. If n equal 2, then return 2. Else return fib n minus 1 plus fib n minus 2. Two base cases, which is the first two, 1, 1. Calls itself twice. This code is inefficient. Inefficient Fibonacci of n equal fib n minus 1 plus n minus 2. So if I'm taking fib of 5, it will be fib of 3 and fib of 4. Fib of 3, it will be fib of 1 and fib of 2. Fib of 4, it will be fib of 2 and fib of 3. Then fib of 1, fib of 2, which are the base cases. Recalculating the same values many times could keep a track of already calculated values. That's why they call it inefficient. But recursively, it is efficient. But we can save like fib 2 and fib 1, and we can keep those. And fib 3 here, it's 2 times. So if we can save it and keep a tracking of them, it will minimize the computation required. Fibonacci with a dictionary. Here is more efficient way. Define Fibonacci efficient and D. If n in D, return D of n, else answer equal Fibonacci efficient of n minus 1D plus Fibonacci efficient of n minus 2D. Method sometimes called memorization. Then D 1 to 1, 2 to 2, which is with dictionary to memorize them. Print fib efficient 6 and D. Initialization dictionary with a base case. Do a lookup first in case already calculated the value. If the value calculated like fib 3, it will use it immediately, the value. No need to call it as a progressive throw function calls. Efficiency gains. Calling Fibonacci of 34 result in 11,405,773 recursive call to the procedure if we use this call. But calling Fibonacci efficient will result in only 65 recursive calls to the procedure. You see how many times we minimize the processing? Using dictionary to capture intermediate result can be very efficient. But note that this only works for procedures without side effects. The procedure will always produce the same result for the specific argument independent of any other computations between calls. So it's efficient with Fibonacci example. It could be not efficient with other examples. Is that clear, guys? Is that clear?
Yes, it's clear.
Yes.
As a yes, it's clear.
Yeah, I understand. So you can go to the resources to apply the code with Python tutor that I gave you the link in the previous classes. It would be very helpful. And if you have any question, don't hesitate to ask me or to ask the TA. Okay, guys. I'll give you like 5 minutes break or 10 minutes. Guys, 5 or 10. Type it in chat.
5.
5, okay. I need 3 votes. Second vote. Ahmed 10. Okay. Third vote. Ten, 5, 10. You are equal. So what should we make it? 7.5. Okay, it's 5:30 now. We'll meet at 5:40, guys. Okay. I'll make a pause for the recording. Okay, guys. Welcome back. So let's start with week 7. And then we'll meet with the group 7. And if you have any other question regarding the project or the midterm or whatever. Okay. Can you see the slides?
Yes.
Okay, good. So now we'll talk about testing, debugging, exception, and assertions. So normally as a programmer, we normally aim for a high quality and analogy with soup. You are making soup, but bugs keep falling in from the ceiling. What do? Check the soup for bug. We call it testing. Keep lid closed. We call it defensive programming, like antivirus or anti-spam or whatever. Clean kitchen, eliminate source of bug. Okay. So what do we mean by defensive programming? Write specifications for function, modularize program, make it small piece, easier to understand, easier to check conditions on input, output, assertions. We call it assertions. Testing or validation, compare input to output, pairs to specification. It is not working. I have the right input, but the incorrect output, or the incorrect input, and for sure, incorrect output. How can I break my program? Debugging, study events leading up to an error, why it is not working, how can I fix my program? So these are the 3 main blocks that I have to take care of. Defensive programming, once I start doing my code, designing my program, I have to, when I'm using function, I have to write the specifications of each function, how it will work, what is the function input, what it should return, how to divide my program into smaller pieces so it's easier for me to find the error and correct it, and to check the conditions of input and output, which we call it assertions. In the other block, we have the testing and validation. We have to compare input to the output and make sure that both are correct. If my program go in infinite loop or it's not stop at certain point, how I can break it to check what make this error or lead to this error. And debugging, I have to study the events lead to the error and why it is not working, what I did wrong to make it's not working perfectly, and how I can fix it. Set yourself up for easy testing and debugging. From the start, design the code to ease this part. Don't make your code complicated and all in one scope. Once you divide it into different function or you use the modularity of code, then you have different scopes, so it's easier for you to follow up. break program up into modules that can be tested and debugged individually. Document constraints on modules. Each module, what are the constraints? What do you expect the input to be? What do you expect the output to be? Document assumptions behind code design. These are a good practices to design your program from the beginning. When are you ready to test? First, you have to make sure that your code runs. Remove syntax error from the code. Remove static semantic errors. Python interpreter can usually find these for you. So Python will do this job for you from the beginning. Have a set of expected results and input set, what you expect the input will be and what are the expected output should be, looks like. What do you have as a kind of testing? We have different kind of testing. We will say unit testing, validate each piece of a program, test each function separately. We call it unit testing, each piece of program tested individually. Regression testing, add test for bugs as you find them, catch, reintroduce error that were previously fixed. Integration testing, does overall program works correctly? Tend to rush to do this. So testing approaches. This is classes of test. We have like another 10 types of test, but this is for software engineering and computer science student, and they have a separate course, call it software validation and testing. But for you guys, it's not required. Those 3 tests are enough. We have different approaches of testing. We have the intuition, the black box testing, the glass box testing. Intuition about natural boundaries to the problem. Def is bigger x, y, assume x and y are integers. Return true if y is less than x, else false. Can you come up with some natural partitions? If no natural partitions, might do random testing. Probability that code is correct increases with more tests. Better options below. So here we are testing just 2 numbers, if x bigger than y or not. So it will return true or false. So there is no natural partitions that I can do more. So I will enter different set of random numbers and do more testing. If all results are correct, then it's better. Black box testing, explore path through specifications. I put input, output, and see if it's correct or not. Black box, I don't look inside the function. A glass box testing, that I'm looking to the actual code of the function. So we are exploring the path through the code. Black box, I put the input, what are the correct output? I put 4 and 5. Is 4 bigger than 5? It should return false. If it returns something else, then I'll say there is error. Glass box testing, then I have to look inside the code and see why it's gave that 4 is greater than 5. Then I have a mistake inside the code. I have to correct this code. So these are the approaches, either random, black box, or glass box testing. Black box testing example, if I have the square root of x and EPS, assume x, EPS float numbers, x greater or equal to 0, EPS is greater than 0, return results such as x minus EPS less or equal RES times RES and less or equal the x plus EPS. Designed without looking at the code. This is the black box. I don't look at the code. can be done by someone other than the implementer to avoid some implementer biases that you know where the mistake, so you try to avoid these kind of example. Testing can be reused if implementation changes. Paths through specification, build test cases in different natural space partitions. Also consider boundary conditions, empty list, singleton list, large numbers, small numbers. For example, we have this one, the case boundary x equals 0 and EPS equal or epsilon equals 0.0001, perfect square 25, and the epsilon is the same, less than 1 0.05, irrational square root 2, extremes 2, extremes 1 divided by 2 times 64, which is times, which mean, what does it mean? Guys, what does it mean?
Power.
Power. Yes. Then extremes, the same one with another epsilon, extremes with third epsilon, and etc. And we'll see if the result is correct or not. Glassbox, use code directly to guide design of test cases, called path complete. If every potential path through the code is tested at least one. What are some drawbacks of this type of testing? Can go through loops arbitrarily many times, missing paths. If you miss some path, then your test is not completed. Guidelines, branches, for loop, while loop, exercise all parts of a condition, null, branches, loop not entered, body of loop executed exactly one, body of loop executed more than once, while loop, same as for loop cases that catch all ways to exit the loop. Here I'll give more and more example and test each piece of code. For example, if we are having the absolute value function, assume x is an integer, return x if x greater than 0 and minus x otherwise, because it's always return a positive number, the absolute value function. If x less than 0, then return minus x, else return x. A path complete test suited could miss a bug. Path complete test suit 2 and minus 2, but a absolute value of -1 incorrectly return -1. Should still test boundary cases. Once we go to the debugging, steep learning curve, goal is to have a bug-free program, tools built in the IDLE and Anaconda, Python tutor, print statement, use a brain to systematic in your hunt. So this is the debugging, because you know, like Python tutor give you the error, then you go and debug it inside the code and correct it. Print statements, good way to test hypothesis. How we do that? When to print, enter the function, then we said inside function X, print this statement. It will give you that this function start working. The parameters. Function will return A as first parameter, B as second parameter. Then in the main program or where we call the function, then you can print what the function returns as a result. Or we use the bisection method, put the print halfway in a code, decide where a bug may be depending on values. You start putting a print statement to make sure that where your code is executed, and you will find here is correct, here is not correct, then the problem in this statement. Study program code. If you don't want to use the print method, then you have to study. Don't ask what is wrong. Ask how did I get the expected result? Is it part of a family? So you have to study your codes. The scientific method is study available data. What I have data from hypothesis, repeatable experiment, pick simplest input to test with. So I'll study the input data range. What is my hypothesis in the program? Where the error coming? Start with the simplest and move on till you reach to the error and catch it. Error messages, easy. This is one of the simplest way that you will receive an error message. Trying to access beyond the limit of the list. Like if we have the list called test, we have 1, 2, 3, and you ask to print test 4, then the program by itself will give you error. You are out of boundary. Trying to convert an inappropriate type integer test as a tuple. You want to convert it, you cannot convert it, then it will give you a type error. Referencing a non-existent variable, A, print A, and you don't have A, then it will give you a name error. Mixing data type without appropriate correction, like 3 as a string divided by 4, it will give you a type error. Forgetting to close parentheses, quotation, etc., like A equal len of list 1, 2, 3, and you didn't close it, it will give you a syntax error. So those are very easy. The error messages, you receive it from the Python interpreter. Logic error, hard to get. Think before writing a new code, draw pictures, take a break, explain the code to someone else, and you can use a rubber ducky method by, like, what's going on? Take a break, go drink juice, walk away. What makes this logical error? Especially with the true and false things. There is no error messages, nothing, but there is an error. The result is not correct. And sometimes, hey guys, I'm doing this and I'm looking for this. What's wrong in my code? Why the result coming like this? So this is the way. Okay. Don't and do. Write entire program, test entire program, debug entire program. Don't write your whole program as a block, one block, all your program, one block. Write functions, test the function, debug the function, write a function, test the function, debug the function, do integration testing. This is what we mean by code modularity. Don't change the code. Remember where bug was, test code, forget where bug was or what change you made, panic. Backup code, change code, write down potential bug in a comment, test code, compare a new version with old version. This is a very good practice because sometimes you forgot what you did changes. So if you want to make changes, save the old one and make a copy and work in a copy. And wherever you change, write that there was a previous bug here, I changed it to this, to keep a track of what you changed. Exceptions and the searches. What happens when a procedure or a function you are doing execution hits an unexpected condition? Get an exception to what was expected. Try to access beyond list limits, like test 4. It will give you index error. Trying to convert an inappropriate type. referencing a non-existing variable, mixing data types, other type of exceptions that you will might have. Already seen common error types, syntax error, Python can't parse program, name error, local or global name not found, attribute error, attribute reference fails, type error, value error, IO error. Like if you want to read from file and the file is not found. But these kind are easy because the interpreter will give it to you. Dealing with exceptions. Python code can provide handlers for exception. Try A equal integer input, tell me one number, B tell me another number, print A over B. Except this is the exception handler, print a bug in user input. For example, if you give B 0, exception raised by an statement in body of a try are handled by the except statement and execution continues with the body of the except statement. If any error happen in the numbers that could not be print A over B, then it will give you bug in user input. Then your input could not be printed as an output. So you use a try and except. Okay, guys? Handling specific exceptions. Have separate except clauses to deal with a particular type of exceptions. Print A over B, print A plus B, except value error, print could not convert to a number if you enter letter A instead of a number. Except zero division error, print cannot divide by 0 if you enter B as 0. Except print something went very wrong for all other errors. And at that time, when you use the try and except, you make sure that your program will not crashes. It will print and it will continue executing. Other exception, you can use else, body of this executed when execution is associated, try, body completes with no exception. Finally, body of this is always executed after a try, else, and except clauses, even if they raised another error or executed a break, continue, or return, useful for a cleanup code that should be run no matter what else happens, like close a file. What to do with exceptions? What to do when encounter an error? Fail silently, substitute default values or just continue. By idea, user get no warning. Return an error value. What value to choose? Complicates coding, having to check for special value. Stop execution, signal error condition in Python, raise an exception, raise exception descriptive string. What do you mean by descriptive string? You write a string that describes this exception. Exception and control flow. Don't return a special value when an error occurred and check whether error value was returned. Instead, raise an exception when unable to produce a result consistent with the function's specification. Raise exception, the exception name, arguments. Raise value error, something is wrong. Here are how you raise it. This is a full example of raising an exception. The code is available in the resources. You can run all of those codes using the Python tutor. Define get ratios L1 and L2. Assume L1 and L2 are list of equal length of numbers. Return a list containing L1 of I divided by L2 of I. Ratios is an empty list for index and range len of L1 try. Ratios that append L1 index and L2 index, except 0 division error, ratios append the float nan, hash nan, not a number, except raise value error, get ratios called with bad argument if you enter in that list like letters or whatever, return ratios. Example of exception, assume we are given a class list for a subject. Each entry is a list of 2 parts, a list of first and a list of last name. For a student, a list of grades on assignments. Test grades, Peter, Parker, first and last name, and 80, 70, 85, Bruce Wine, 100, 80, 74. Create a new class list with name, grades, and average. This is how we create it. Example of code, def get stats, class list, a new stat. For ELT in the class list, a new stats, append ELT of 0, ELT of 1, average of ELT 1. Return a new stats, def average grades, return sum of these grades. So here example of code. Error, no grade for a student. For length of a grade is 0, especially for this student. So it will not give me the correct one. So how we can handle if no grade is entered for that student? Get division, 0 division, float division by 0, because try to return sum, and here is 0. Option 1, flag the error by printing a message. Def average, try return some grades, except division by 0 error, warning, no grades data. Running on some test data gives warning, no grades data. Peter, here it will give you none. Decide that a student with no grades gets a 0. No grade data, return 0, 0. So here we add 0, 0, 0.0, that the student gets 0 because there is no data. This is another way. Assertions, want to be sure that assumption on state of a computation are as expected. Use assert statement to raise an assertion error exception if assumption not met. An example of good defensive programming if you use assertion error. How to do that? Def average assert len grade not equal 0, no grades data, return some grades dot len. So function ends immediately if there is no grades. Raise an assertion error if it is giving an empty list for grades, otherwise runs okay. This is another way, and it's a good defensive programming from the beginning. Assertion as defensive programming. Assertion don't allow programmer to control response to unexpected conditions. Ensure that execution halts wherever an expected condition is not met. Typically used to check inputs for functions, but can be used anywhere. You can use it to check output of a function to avoid propagating bad values, can make it easier to locate source of bug. So with this assertion thing, also you can locate your bug. Where to use assertion? Goal is to spot bugs as soon as introduced and make it clear where they happen. So we use it as a supplement. Raise exception if user supplies bad data input. Use assertion to check types, invariance or constraint or violation. So these, like, we give you like an introduction to software validation and testing when you write your code in Python. As I told you, all these examples, you can run them in Python tutor, and it will show you how these can be executed. If you have any question before the midterm, guys, don't hesitate to send me an email or to the TA. asking your question via email, or we can set up a meeting and we can discuss everything. So if you don't have a question, you don't have any question regarding the proposal or midterm, as I said, the midterm require 20-25 minutes as maximum. I give you 60 minutes. It will consist of some multiple choices, some short answers to questions, or to write like a small piece of code, or to find the output of certain code or the error in certain code. These are kind of questions that you will have. Study well, guys. Practice, practice, practice. And I wish you the best of luck. If you don't have any question or any extra clarification about the project, you can leave now. Group 7 and any other group you have a question about the proposal, you can stay. Thank you and wish you a happy reading week and a successful reading week. And I wish you to get the best grades in your midterm in different courses. And see you in November 8th. We will start again with our midterm from 4 to 5, then we'll continue with our class. So you can leave.
Thank you.
Yeah, thank you guys. And for group 7, please stay. And any other members of any group, or if you have a question, don't hesitate to ask.
Professor,
Yes.
I'm group 7. I have
Yeah.
a question about the project.
Okay, go ahead.
Our topic is the image processing, and
Yes.
you asked us to compare and analyze more than 2 image processing techniques. I'm confused about the techniques defining. Is it means like for image processing, we should choose 2 totally different fields, like one is enhancement of image and the other one is the detection of image, or we just choose specific one field, like for example, in the field of enhancement of image, we can choose like specific techniques like histogram, equalization, and other ways to deal with the enhancement.
This is what I mean.
Oh, okay.
So for the set of algorithm, like you use like to the enhancement, the object detection, whatever you choose, there is different algorithms that solving the same issue.
Okay.
Okay, so you have to compare 2 or more of those techniques, and you can compare them, like you will implement them, you will show the different result of the same image with those techniques, and you will talk about the complexity, which one is better and why.
And for the complexity, is the complexity for the algorithm, or
Yes, of the algorithm,
okay.
like the big O of that algorithm, or the omega notation, or whatever.
Okay, thank you, Professor.
You are welcome. Any other question, guys?
Professor,
Yes.
the midterm will cover up to what we have discussed today.
Yes.
Okay.
So it's from week 1 to week 7.
Okay. And I have one more question regarding the project.
Yes.
So our is regarding a virtual assistant, which involves different packages of speech to text conversion. So you mentioned about the complexity, and I mean, how can we calculate the complexity of external packages that we are using?
No.
Okay.
We are not talking about packages, we're talking about algorithms that have been used. You choose implementation or analysis?
It is implementation.
So the code you will implement, okay, you might use packages, but the algorithm you use, you should know the complexity of that algorithm. Because in packages, you are using different techniques, right?
Yes, but sometimes it is very difficult to know that, because suppose we are using Google speech to text.
You can Google it
The
and
algorithms
find it. You can Google it and find it. And if you couldn't find, you can explain at that time. No worries.
Okay, okay, thank you.
You're welcome. Questions? I'll stop recording right here. Or okay, Ahmed, go
Professor?
ahead.
Yes, I have a question regarding lecture number 7, the one we just finished right now, a while
Yes.
ago. It is included in the exam and the
Yes.
midterm.
Yes.
How
If you go
can
to
we?
the course outlines,
Yeah.
you will find what is covered in midterm.
Okay.
Okay, I can share with you now the course outline. Just a second. Just give me a second, Ahmed.
No problem. Lecture number 7 was kind of dense.
Why?
Basically, all of them are abstract ideas. How we can put these ideas into practice and retain them in the memory on the long run?
Everything I talk about you, I give you an example of code, and I give you that code to run it in the tutor.
Okay.
And to see what's going on.
Okay.
Yeah. So if you see here, here's what we call it week 1. It's not actual week, which is a handout number.
Yeah.
So here at week 7, then we have a week 8, then we have the midterm.
Okay. Okay.
Okay. And
Okay.
here also, if you go in the midterm topics 1 to 7.
Okay, understood. Clear.
Yeah. So for example, assignments, it's 1 to 9, which is 1 to 3, 3 to 6. Assignment 2 will cover 3 to 6. Then assignment 3 will cover 6 to 9. Quizzes, what will be covered. Quiz 2, what it will cover. So a quiz 2, it will cover 8 to 11. And then a quiz 1, we covered 1 to 3. So this is how I designed the course to make sure that every single component is evaluated.
Okay, understood. Understood.
Yeah.
So repeating the code examples that in lecture 7 should be enough for us to grasp all the ideas in it, right?
Yes, yes. You know, it's simple, but maybe it's in new terms to you guys since you are not
Yes.
software engineering.
Yeah.
But since it's a programming course, you should take this in the undergrad. Maybe you took it in different languages. You are new to Python.
Yeah, I'm new to Python.
Yeah. So just to the exception handling, it's available in any language you took before, even Fortran in 1990s.
Okay.
With
Okay.
any programming course, we have that how to handle, how to debug your program.
Okay.
So how to debug it in Python? It's one of the simplest languages ever.
Okay.
If you see in C++, you have to write like sometimes 20 lines of code to handle a problem. But here you just like put an assertion, flag, try, and accept. It's simple. Just you have to try it, because that's why I said at the end of the class, practice, practice, practice.
True.
How much you practice examples, you will understand the concept. And if you have any doubt, just send me an email and we can do it together via Zoom.
Okay, excellent.
Or
Sounds
with the
great.
TA, whatever it's comfortable for you.
Okay, sounds great.
Okay.
Okay, Professor. Thank you very much.
Best of luck, guys. Best of luck.
Thank you. Bye.
Questions?
Hello, Professor. I have some question about the assignment 2. So on the outline, it says till this Sunday, but I don't see the assignment 2 on the out yet.
Why you didn't see it?
I don't know, but
I don't release assignment 2 yet. So here what we're saying. Tentative due date, right?
yes.
So it's not fixed. As in the first class, if you back to the video recording, I said I'll try to make sure that no changes with the quiz 1 and 2, midterm, and the presentation date. Any
Okay.
other, I'll try to meet that one. But for example, you have like after tomorrow that the like it's a due date for the proposal, project proposal, but because the group forming took longer than expected. So I'll not be harsh to put assignment 2 to be due in 4 days after the proposal. And you know,
Okay.
that's why I don't push hard. So I will release it on Wednesday after you submit the, what we call it, the proposal. All groups submit their proposal. I will release assignment 2 and I'll make the due date after the midterm 2-3 days.
Okay. Okay.
So I'll give you enough time to do that.
Okay.
So I don't want to think to come overlap with each other. It's
Okay.
easier for you guys to have one task per time. Because I know you have another courses, so I don't want it to be like hard on you guys to have multiple tasks to be submitted with a short period of time.
Okay.
Okay, so don't
Thank
worry,
you.
I will release it Wednesday evening or Thursday morning.
Okay. Okay. Thank you.
Good luck, guys. Ahmed, do you have any? Oh, Ahmed left. Hingong Q, do you have anything else? Chia, she left. Lee, do you have anything? Hello. Okay, I'll stop recording and see you